Good morning, everyone. Today we're going to be just reviewing a little bit of factoring and solving, and then you'll complete the worksheet attached to the notes on factoring mostly different types of polynomials. So the first thing is just the zero product property. This is a property that you all know really well, but it just says that if you want to solve something, it needs to be in factored form. And again, if the product of two real numbers or two real expressions equal to 0, then you can set each piece equal to 0 in this case. So we could set 2x equal to 0, we get x equals 0, and we could solve x minus 4 equals 0, so we'll get x equals 4. Okay, we could do the same thing here, and we'll get x equals 3 and x equals 9. Nothing new, just kind of reviewing that we have when we solve something, we can solve it when it's in factored form. Okay. Next, so one of the more simple types of polynomials when it has two terms is a binomial. So the way that we can factor a binomial is by factoring out a GCF, or a greatest common factor. So the first one we're going to start with is 4x to the fourth plus 24x cubed. Okay, and this has a highest power of 4. We want to factor out what we call the GCF out of both of these. Okay, so first we're going to say what is the largest number that goes into both 4 and 24. So large number is 4, so we're going to pull out a 4. And then our x values are x to the fourth and x cubed. So we can only pull out an x cubed in this case. And then to see what is left inside the parentheses after we factor out, we can always, like we did when we graph trig functions, we can always divide by whatever we factor out, and that will get us what's left over. So for example, 4x to the fourth divided by 4x cubed, x to the fourth over x cubed just gives me x to the first power on top. So that would just be x left, plus, again, we could do the same thing with 24x cubed divided by whatever we factored out, which is 4x cubed. We're going to get 6, and then the x cubes cancel, so it's just x plus 6. How can you check yourself? Distribute it back in. 4x cubed times x is just 4x to the fourth. That's what we wanted. 4 times 6 is 24x cubed. So that's what we got. So this is the factored form. And of course, if we wanted to solve it, we just set both pieces equal to 0 and we could solve. You could do the same thing with the 8y squared minus 24y. You say to yourself, okay, what's the largest number that goes into both 8 and 24? It's just going to be 8. So we're going to factor out 8. And we're also going to factor out, in this case, we have y squared and a y, so we can only factor out one of those y's. What are we left with? So if we divide, we're going to be left with 8, just y, minus, and then if we divide, the y's will cancel. 24 divided by 8 is just 3. Again, you can distribute this back in. So you want to ask yourself, what's the smallest number, or the smallest variable that goes into, or the largest number, largest variable that goes into both of these. Okay, let's go down a little bit. So the next section is all about factoring trinomials. And when we factor trinomials, and we had kind of talked about this a little bit in class throughout the year, but we always have the standard form of a trinomial, which is ax squared plus bx plus c. Now, it's the simplest when a is equal to 1, so when that number in front is equal to 1. Okay, so that's what we're talking about first, and we're talking about when c is positive, c is negative, but all of these factoring methods, and you can use the examples to help you that I have up here, all of these factoring methods when it's a trinomial boil down to one thing. So when the number in front is 1, and we're just factoring something of this form, so x squared plus bx plus c, where the number in front is 1, I like to use the expression am, like the morning, am. Okay, what adds to the middle multiplies to the last. So it'll be what adds to b, whatever b is, and multiplies to that third term, whatever c is. Okay, and their signs would stay the same. If it was -5 for b, it would be -5 down here. So let's look at a different example really quick. Okay, so if we were going to factor x squared plus 10x plus 16, we want to know what adds, so we're going to use that am I talked about. What adds to the middle multiplies to the last. So what adds to positive 10 and multiplies in this case to positive 16. So I always like to start with the 16 and look at the factors. So factors of 16 are 16 and 1, so that's not going to do it for us because that won't add to 10. Other factors of 16 are 4 and 4, but they aren't going to do it because, again, they don't add to 10. And the last two factors, which are 8 and 2. And if you add them together, they will multiply to 16, but add to 10. So my factors are x plus 2 times x plus 8. Okay, this process, as long as that number in front does not change, it's still 1, this process doesn't change if the C value is negative. It's still what adds to the middle multiplies to the last. So it adds to 4 and multiplies to negative 21. Still, start with the multiplication. Okay, you're going to say what multiplies to 21. So our factors of 21 are 21 and 1 and 7 and 3. Okay, 21 and 1 are not going to in no way add to 4. 7 and 3. Well, in order to multiply to a negative, and you can look at the example up here as well, one of the numbers has to be negative. So which one is negative? Well, since it's a positive 4, they're adding to a positive, the larger number has to be positive, so the 3 would be negative. So you want to say to yourself, do the numbers 7 and negative 3 multiply to negative 21? They do. And add to 4, and they do. Okay, so my factors would be x plus 7 and x minus 3. You can always check yourself by FOILing. So if you were to FOIL this out, you would get x squared plus 4x minus 21, which is what we want. Okay, and as we move on to our last two examples, remember you can play this back as many times as you need. When we have a number in front, how does this approach change? Well, this approach will change when there's a number in front because there are two ways you can go about it. Okay, the first thing is you can look and see, is there any number that you can factor out of all three of these? So if I pull out a 5 from all three of these and divide by 5, I'd be left with x squared plus 15 divided by 5 is 3x. 10 divided by 5 is 2. So I just divided all of these by 5 to see what I was left with. Okay, now you can kind of ignore the 5, just leave it out front, and you can factor on what's on the inside just like we did in the last problem. So it adds to the middle, multiplies to the last. Just don't forget to leave that 5 out in front. Okay, so two numbers that add to the middle, which is add to 3, multiply to 2, are just 2 and 1. They add to 3, multiply to 2. So it'll be x plus 2, x plus 1. Okay, so this would be the full answer. Don't forget to leave that 5 out in front because that changes the problem a little bit. Now what about, I'm just going to add one more on here. What about in the instance that you can't simplify out, like divide everything by 5? So say we had something like 2x squared plus 3x minus 9. Well, in this case, we still want to know what adds to the middle, but we make like a little tent. We want to know now what multiplies to the first times the last. So in this case, it would multiply to negative 18. Negative 2 times negative 9. This is only when you have the number out in front. That's not 1. So what two numbers add to 3 but multiply to negative 18? Okay, the first times the last term. So A times C, as some of you may know it. Those numbers are going to end up being 6 and 3. But since they need to multiply to a negative, the 3 is going to be negative because they're adding to a positive. But you can't just make this x plus 6, x minus 3. So what are you going to do? Well, you need to break it up. Okay, and this is going to lead us into our next example. So we're going to break it up. So you rewrite the first term and you rewrite the last term as is. That 3x in the middle you break down into these two values. So what do I mean? So rather than writing just plus 3x in the middle, we would write plus 6x and then minus 3x. So whatever two numbers you find, put an x next to them and put them in your equation for the middle term. Now we split it and we factor by grouping, which you'll see below here. So you ask yourself, just like we did earlier with the binomials, what do these two have in common? A 2x, we pull it out. What's left? An x plus 3. What can we pull out here? You can pull out a -3. What's left? X plus 3. When you factor by grouping, whatever is in these two factor pairs should be identical. Now, what's your final factored answer? You take everything that's in front, that becomes one factor, and then what's inside the parentheses is another. You don't need to repeat it twice. Okay, and you're going to see that again a little bit below with the factor by grouping. There are also really good videos on Khan Academy, but this is a review, so you could probably find it in your textbook. If you want to look at the Sullivan link, whatever it is on there, and Google it, right? Use your resources to help you, especially when I'm not here. So our last examples are just factoring by grouping, and we'll wrap up this video. When you factor something that has 4 terms, look and see if there's anything you can factor out of all 4. In this case, there's nothing that you can pull out of all 4. So now to factor by grouping, just like we did above, when you have 4 terms, you're going to split the equation in half. You're going to factor the first 2, and then the next 2. So out of the first 2, we have x cubed and 3x squared. We can pull out an x squared. We'll be left with an x, a plus, and then a 3. Again, FOIL it back in to check yourself. You will get the original. The next one. Now, just like I said before, whatever you have in the parentheses here, you should have here. So we should expect to have x plus 3 inside here. So what will we factor out? A 2. Whatever you factor out, you divide by. So we'll be left with 2 times x plus 3. What's the answer then? The 2 things in front are just my groupings. And then you take one of the groups of parentheses. You don't need both, you just take one. Okay? And that is, we're not going to do example B. So that is pretty much where I'm going to leave you all today. You can work on that worksheet. You can play back anything in here, and you can also skip around the video if you understand some parts and not others. If you have any questions, send me an email, send me your mind, and I'll try my best to get back to you. But otherwise, work on that, submit it on Classroom if I ask you to, and use your resources online to help you.